let us do areas. Question number 1. The area of the region bounded by the parabola y is equal to x square and x axis and two ordinates given, x is equal to 0 and x is equal to 2. How many square units? A is given 8 by 3, B is given 5 by 3 and C is given 3 by 2, D is given 1 by 2. Now let us find what is the answer. So question number 1. Area bounded between parabola y is equal to x square, x axis and two ordinates given, x is equal to 0 and x is equal to 2. So let us find the solution for this. Y is equal to x square, it is a parabola, vertical parabola. So this is y is equal to x square and this is x axis. X is equal to 0 and x is equal to 2. So x is equal to 0 means y axis and x is equal to 2 means vertical line. Now we want this area, right? And how to find this area? Now let us integrate from 0 to 2. Integral 0 to 2 y dx, right? What is y? X square dx. Now what is x square integration? That is x to the power of n integration, x to the power of n plus 1 by n plus 1. That is x cube by 3 and the limits given 0 and 2. First you submit upper limit 2 cube minus submit 0, that is 0 cube, any 0 only. So what is your answer now? 8 by 3. So first option, that is answer A. Now question number 2. The area bounded between y is equal to x square plus 2, again parabola, and x axis and two ordinates, x is equal to 1 and x is equal to 2. So let us try this. Question number 2. Parabola x square plus 2 and x axis same like previous and two ordinates, that is 1 and 2, x is equal to 1 and x is equal to 2. Same old method, this is x square plus 2. Let us see what is the parabola, vertical parabola. Y is equal to x square plus 2 and x axis, this is x axis and x is equal to 1 and x is equal to 2. So this is one ordinate, this is another ordinate, this is x axis and this is your curve y is equal to x square plus 2, parabola. Now required area, this shaded area is required area. Let us find this area and let us find the answer. So area bounded between these two, definite integration, integral 1 to 2 y dx. Okay. Now x square integration x cube by 3. Okay. What is 2 integration? 2x and apply the limits. Let us now submit the upper limit, x is equal to 2. If you put x is equal to 2, 2 cube by 3, 8 by 3 and 2 2s are 4. Lower limit to be subtracted, put 1, 1 by 3 and put 1, 2. So what is resultant area? 8 by 3 minus 1 by 3, 4 minus 2. Now if you consider LCM, 3 into 2 how much? 6. 6 plus 7, 13. So what is your final answer? 13 by 3. So what is your right option? Answer is C. Question number 3. So the area bounded between the parabola x square is equal to 4y and x axis and x is equal to 2. Options are given. A is 1, B is 2 by 3 and C is 4 by 3, D is 8 by 3. Out of these 4, what is the right answer? Let us do. Parabola given x square is equal to 4y. And x-axis, of course, another ordinate given x is equal to 2. Okay. Now, let us see what is the area. So, this is a vertical parabola. Again, x square is equal to 4y. Now, x-axis and x is equal to 2. So, this is what required area. This is y is equal to 0. Now, let us find this area. Area is y dx, that is x square by 4, and x-axis and x is equal to 2. So, 0 to 2. So, same old method, x square integration is x cube by 3 between 0 and 2. Let us submit the upper limit, that is 2. If you submit 2 cube by 3 minus, when you submit 0, become 0. So, if you cancel, became 2 by 3 square units. So, right answer is B. Question number 4. Area bounded between the parabola x square is equal to 8y, x is equal to 4 and x-axis. Options: A is 2 by 3, B is 4 by 3, C is 8 by 3 and D is 10 by 3. Let us see what is the right answer, right? Area bounded between the parabola x square is equal to 8y and x-axis and one ordinate x is equal to 4. Let us see the diagram, solution diagram. So, this is very clear. X square means vertical parabola 8y and this is your x-axis and one ordinate x is equal to 4, vertical line. Now, area bounded between these two, this is the required area. So, let us find 0 to 4 integration, definite integration. Required area, what is required area? Integral 0 to 4 y dx. What is y? X square by 8 dx. Keep 1 by 8 outside. What is x square integration? X cube by 3. Apply the limits. If you put 4 cube, that is 64 by 3 minus 0. So, 8 8s are. So, final answer is 8 by 3 square units. So, what is right option? Answer is C. Question number 5. Area bounded between the parabola y is equal to x square minus 3x plus 2 and x-axis and two vertical lines given, x is equal to 0 and x is equal to 3. Options are given: A is 3 by 8, B is 2 by 3, C is 3 by 5 and D is 9 by 2. Let us see what is the right answer. Question number 5. Area bounded between the parabola y is equal to x square 3x plus 2 and x-axis and two ordinates given, x is equal to 0, x is equal to 3. Now, area bounded between the parabola y is equal to x square minus 3x plus 2, x-axis, and x is equal to 0 and x is equal to 3. Solution diagram 1 and 2. It is intersecting x-axis at 1 and 2. So, we know the parabola vertical upwards. This is nothing but 2, 0, 2. And x-axis, this is x-axis, x is equal to 0, that is y-axis, and x is equal to 3. So, area bounded between this area and this area and this area. So, let us try to find this area. So, 0 to 1, integral 0 to 1, this is upwards. So, x square minus 3x plus 2. And which is downwards is opposite sign. And 2 to 3. So, this is again upwards. Right? Now, x square integration x cube by 3. X square, x integration x square by 2. 2 integration 2x. Let us apply 0 and 1 minus same integration x cube by 3, x square by 2 into 3, 2x, but limits are different. 1. Finally, same integration again x cube by 3, 3x square by 2 plus 2x between 2 and 3. Now, if you submit the values, you get final answer after simplification 1 by 3, 3 by 2 and 2. When you put lower limit, it becomes 0. So, no need to put that. First bracket is over. Here, when you put 2, 8 by 3. 2 square by 2 and 2 into 2. This is over. Minus, any minus into minus, plus. Submit lower limit. 1 by 3, 3 by 2 plus 2. And finally, last one. 3 cube by 3. 3 square into 3. And 3 into 2. When you subtract 2 cube by 3 and 2 square by 2. Next, 2 to the 4. When you submit lower limit, this is the last one. So, if you simplify this, you get final answer 9 by 2. So, right answer is D. Next question. Question number 6. Area bounded between x-axis and parabola y is equal to 4x minus x square minus 3. 4 options are given. A is 1 by 3, B is 2 by 3, C is 4 by 3 and D is 8 by 3. Let us see what is the right answer. Question number 6. Area bounded between the parabola given y is equal to 4x minus x square minus 3 and via x-axis given. So, let us see this. This is a vertical parabola again. Now, let us find these roots where it intersects the x-axis. So, we get like this. So, it is very clear 1 and 3. So, let us find 1 and 3. So, minus x square means parabola is down. So, this is the parabola, required parabola. Now, x-axis is given, this is x-axis. So, only two boundaries given, so we have to find this area. So, how to find the shaded area? See here. Area required, integration 1 to 3 and 4x minus x square minus 3. Now, let us go for the integration. X square by 2 into 4, x cube by 3, 3x. Let us apply the limits 1 and 3. When you submit 3, it becomes 2 into 9, 18. 3 cube by 3, 27 by 3 and 3. 3 into 3, 9. When you apply lower limit, minus 2 plus 1 by 3 plus 3. Now, 9, 9, 18 cancel. 3 minus 2, that is 1. 1 by 3 plus 1. So, required area 4 by 3. So, what is the right option? Answer is C. Now, question number 7. Area bounded between the curve, that is a parabola, y is equal to 4 minus x square and y is equal to 0 and y is equal to 3. Two horizontal lines. 4 options are given. A 10 by 3, B 32 by 3, C 13 by 6, D 23 by 3. Now, what is the right answer? Question number 7. Area bounded between the parabola y is equal to 4 minus x square and y is equal to 0, y is equal to 3. So, let us look at this area. Solution diagram. Because x square is there, this is vertical parabola, and if you make y is equal to 0, it intersects the x axis plus 2 and minus 2. So, consider minus 2 plus 2. Because minus x square is there, downward parabola. It will be like this. But of course, this is nothing but 4 if you put x is equal to 0. Now, y is equal to 0, this is x axis, and y is equal to 3 somewhere. So, now required area, this is shaded area, this area is required. Let us find what is the area. So, first minus 2 to plus 2 or let us consider this area 0 to 2, right. This total area when you apply the parabola. So, let us go for the upper curve 4 minus x square dx. So, what we get here, integration 4x minus x cube by 3. 0 and 2. 4 into 2 minus 2 cube by 3. Lower limit is 0, so no need to write. 3 8s are 24. 24 minus 8, 16 by 3. But this area includes the total area. But we want this area to be subtracted. Okay. Now, let us see where it is intersecting. Put y is equal to 3. So, x became 1. So, this is 1. So, I am finding now this area. That should be subtracted. So, what area should be subtracted? Let us see. 0 to 1. Same. 4 minus x square dx. 4x, x cube by 3, 0 and 1. If you put 1, 11 by 3. So, of course, when you apply 0, it becomes 0. Now, let us subtract. 16 by 3, 11 by 3. So, 16 minus 11, 5 by 3. And this area we got 5 by 3. Now, if you double it, required area will be 10 by 3 square units. So, what is the right answer? 10 by 3 square units. So, first option, that is answer A. Question number 8. Area bounded between the parabola y is equal to x minus 4 into x minus 1 along with the x axis. So, area bounded between the parabola and x axis. 4 options are given. A is 9 by 2 square units, B is 6 by 5 square units, C is 9 by 5 square units and D is 9 by 4 square units. So, let us see what is the right answer. Question number 8. Area bounded between the parabola y is equal to x minus 4 into x minus 1. Okay. And one more boundary is given, x axis. So, it is very clear, roots are 4 and 1. So, intersecting x axis at x is equal to 4 and x is equal to 1. So, let us try to put the diagram. This is 1, this is 4 and it is x square. So, upward parabola. So, parabola will be like this and it is given x axis, this one. Now, we have to find this shaded area between 1 and 4. So, let us try find out this area, right. Now, area required, integral 1 to 4 x square 4x and x 5x and 4 into 1 4 dx. Now, x square integration x cube by 3 5 into x integration x square by 2 4x. Now, let us put 1 and 4, but it is given below the x axis. So, what we understand, it is negative area. So, to make it positive, absolute means modulus, or you can put minus also. So, let us see the final answer. Submit 4, 64 by 3 and 4 square by 2, 16 by 2, 8 into 5 and 4 4s are 16 minus apply lower limit 1 by 3, 5 by 2 and 4. This is your required answer. So, what is right answer? 9 by 2 square units. Answer is A. Question number 9. Area of the region lying between the line x minus y plus 2 is equal to 0 and the curve, that is parabola x is equal to root y. What is the area between this line and parabola? Given that options A is 9 square units, B is 9 by 2 and C is 10 by 3 and D is 10. Let us see what is the right answer. Question number 9. Area bounded between the line x minus y plus 2 and the parabola x is equal to root y. So, this is nothing but vertical parabola. Y is equal to x plus 2 and y is equal to x square. So, let us find the point of intersections. So, solving this line and parabola. So, point of intersection or roots, x is equal to minus 1, x is equal to 2. Now, let us try to put this diagram. Now, y is equal to x square is a vertical parabola. This is y is equal to x square. Of course, this is origin, this is x axis and this is y axis. Now, line intersecting at minus 1 and 2. So, approximately minus 1 and 2. So, the line is like this. Now, the required area, because it is given root y, only positive curve we get, right? X cannot be negative. So, I am taking only from here to here, that is 0 to 2 only. So, let us try to find this area. Area integration 0 to 2 and x square. So, line is upper. So, let us first take the line x plus 2 minus x square dx. So, x integration is square by 2. 2 integration is 2x and finally x square integration x cube by 3. Apply the limits 0 and 2. 2 square by 2, 2 into 2 and 2 cube by 3. Of course, when you apply 0, it's 0 only. 2 plus 4 how much? 6. 3 into 6. Taking LCM, 18. 18 minus 8, 10. 10 by 3 square units. So, what is the right option? Right option is C. Answer is C. Now, question number 10. The area bounded between the curve y is equal to 2 cos x, y is equal to 0 and x is equal to pi by 6 and x is equal to 0. 4 options are given. 10 square units, that is first option, and second option B 1 square unit, third one C 2 square units and fourth one option D 5 square units. Let us see what is the right answer. Question number 10. Area bounded between y is equal to 2 cos x, right, and y is equal to 0, x axis. 2 vertical lines given, x is equal to 0 and also pi by 6. Now, let us trace this curve. So, solution diagram. This is x axis as usual, y axis and origin. Now, put x is equal to 0, 2 into cos 0, that is 2 into 1. So, at 0 it is somewhere here. Now, put pi by 6. What is cos pi by 6? Cos 30. root 3 by 2 into 2, that is root 3 by 2. So at pi by 6, it is root 3 by 2 somewhere over here. So this is cos curve and area required is between 0 and pi by 6. This is your 2 cos x, right? Now we have to find this area. Let us see what is the right answer. Required area, integration 0 to pi by 6 and 2 cos x. What is cos x integration? Sin x. Apply the limits. Let us put upper limit first, pi by 6. So sin pi by 6, 1 by 2 minus apply 0, sin 0. So what is resultant area? 1 square unit. So right option is B. Answer is B, 1 square unit. Next question. Question number 11. The area of the region bounded by the curve y is equal to sin x and x axis and two ordinates given, x is equal to 0 and x is equal to pi by 3. 4 options are given. A is 1 by 3 square units, B is 1 by 2 square units, C is 3 by 2 square units and D is 2 by 3. Let us see what is the right answer. Question number 11. So question number 11. Area bounded between, that is sin x, y is equal to sin x. Okay. And two ordinates given, vertical lines, x is equal to 0, x is equal to pi by 3. So let us see the solution diagram. X is equal to 0. If you put x is equal to 0, sin 0, what is sin 0? 0, right? X is equal to pi by 3. Sin pi by 3, sin 60, any root 3 by 2, somewhere over here. So somewhat sin x curve is like this. So this is x is equal to pi by 3. So we have to find this area, right? Now let us find this resultant area. Area required, integral 0 to pi by 3 sin x dx. What is sin x integration? Minus cos x. And let us apply the limits. Now submit upper limit, pi by 3 minus cos 60. Cos 60 value 1 by 2 square units. Minus into minus, lower limit to be subtracted. Apply 0, cos 0, 1. So 1 minus 1 by 2. What is resultant? 1 by 2 square units. This is 1 by 2 square units. So what is right answer? Answer is B. Second option is right answer. Question number 12. The area bounded between the curve y is equal to sin x, x is equal to pi by 4 and x axis. So 4 options are given as usual. A is root 2 plus 1 by root 2, B is root 2 minus 1 by root 2 and C is root 2 minus 1 by root 3 and D root 3 minus 1 by root 2. Let us see what is the right answer. Question number 12. Question number 12. Area bounded between, what is the curve given? Y is equal to sin x. Okay? Y is equal to sin x. And x is equal to 0 and x is equal to pi by 4 x axis. So let us try to put this diagram and find the area. as usual x axis, y axis. Now put x is equal to pi by 4. Sin pi by 4. What is sin pi by 4? 1 by root 2. So somewhere 1 by root 2. If you put 0, 0. If you put pi by 2, 1. So somewhat sine curve will be like this. Right? If you prolong it, it will come like this. But we want area only between sine curve, x axis and up to pi by 4 only. So let us see what is the right area. So this area is required area. Let us find this area. Area required, integration 0 to pi by 4 sin x dx. Right? What is sin x integration? Minus cos x. Okay? Now apply 0 and pi by 4. First you apply upper limit pi by 4 minus cos pi by 4. What is cos 45? 1 by root 2. Minus and minus plus cos 0, that is 1. You can leave like this, but according to option, let us simplify. Take LCM. Minus 1 plus root 2 by root 2. It is nothing but root 2 minus 1 by root 2 only. Square units. So what is the right option now? I think answer is B. Answer is B. Question number 13. The area of the region bounded by the curve y is equal to sin x, x axis and 0 to 2 pi. So from 0 up to 2 pi. So 4 options are given. A is 4 square units, B is 3 square units, C is 2 units and D 1 square unit. Let us see what is the right answer. Question number 13. Area bounded between y is equal to sin x. What are the limits given? X is 0 to pi, 2 pi and x axis also. So let us try to put this diagram so that we can understand what is the area. So as usual, x axis and y axis. You know very well 0 to 2 pi, 0, say pi by 2, pi, 3 pi by 2, 2 pi. Sin 0, 0. Sin pi by 2, 1. Sin pi, 0. Sin 3 pi by 2, minus 1. And sin 2 pi, 0. So its sine curve is like this. Because of symmetry, you find only this much area and make 4 times. Actually, this is total area required, but between 0 to pi by 2 integrate and how many times? 1, 2, 3, 4. So total 4 into this required area will give you total area. So let us see. So required area, integral 0 to pi by 2 sin x dx. I am finding only this much. Actually total area is 4 times of this. Sin x integration minus cos x. Apply 0 and pi by 2. Cos pi by 2, 0. Minus of minus. Cos 0, 1. So this is 1 square unit. So this is 1, this is 1, this is 1, this is 1. So what is total? 4 units. Total is, this is 1 unit, this is 1 unit, this is 1 unit, this is 1 unit. So total required area, total area, 4 times of 1, 4 square units. So answer is A. Next question, question number 14. The area bounded between the curve y is equal to cos ax, one arc of the curve. What is the area? Only one arc. Let us see what is the right answer. First option is given 2a, b is given 1 by a, c is given 2 by a, and d is given 2a square. So what is the right answer? Let us see. Question number 14. Area bounded by y is equal to cos ax, one arc. Let us see what is one arc. So as usual, y axis, x axis, origin. Now let us submit 0, cos 0, 1. Let us apply here pi by 2a. So it becomes 0. Pi by 2a. So the curve. This is one arc. Let us see what is this area. Okay. This is the required area. Required area 0 to pi by 2a. Cos ax. What is cos integration? Sin. Ax derivative is a. So we divide. If it is derivative, we multiply. If it is integration, we have to divide. Apply the limits. Put pi by 2a here. A cancel. Sin pi by 2, 1. Put 0, sin 0, 0. So what is your answer? One arc, 1 by a square units. Right answer is B. Question number 15. The area bounded by the curve y is equal to sin x, y is equal to cos x, and y axis. So what is the area? Options are given. A is root 2 square units, B is root 2 plus 1, C is root 2 minus 1, and D is root 2 plus 2. So what is the right answer? Let us see. Question number 15. So area bounded between y is equal to sin x, y is equal to cos x, and y axis. So let us see this diagram. So let us take the origin, x axis, y axis. I am taking up to pi. So let us try to draw the sin x curve. Sin 0, sin 91, sin 180, 0. So this is sin graph, sin x. Now cos x, cos 0 is 1, cos 90 is 0, cos 180 is minus 1. So cos curve is like this. Now we want the area required bounded between sin x and cos x and y axis. So this area. Of course, this point of intersection pi by 4. So now we have to find the area between the y axis and 0 to pi by 4 sin x and cos x. Let us see that. Required area 0 to pi by 4 integration. What is upper curve? Cos x is upper curve. Lower curve is sin. So cos x minus sin x. Right? Cos x integration is sin x minus sin x integration is minus cos x, minus minus become plus. 0 and pi by 4. First apply upper limit. Sin pi by 4. Cos pi by 4 minus sin 0, 0 minus cos 0, 1. So 1 by root 2 plus 1 by root 2, 2 by root 2, that is root 2, minus 1. So root 2 minus 1 square units. So answer is C.